The Boeing 777 is a family of long-range wide-body twin-engine jet airliners developed and manufactured by Boeing Commercial Airplanes. It is the world's largest twin-jet and has a typical seating capacity for 314 to 451 passengers, with a range of 5,235 to 9,500 nautical miles. Commonly referred to as the 777, its distinguishing features include the largest diameter turbofan engines of any aircraft, 6 wheels on each main landing gear, fully circular fuselage cross-section, and a blade-shaped tail cone. Developed in consultation with 8 major airlines, the 777 was designed to replace older wide-body airliners and bridge the capacity difference between Boeing's 767 and 747. As Boeing's first fly-by-wire airliner, it has computer-mediated controls. It was also the first commercial aircraft to be designed entirely with computer-aided design. The 777 is produced in 2 fuselage lengths as of 2014. The original 777-200 variant entered commercial service in 1995, followed by the extended-range 777-200 in 1997. The stretched 777-300, which is 33.25 feet longer, followed in 1998. The initial 777-200, 200ER and -300 versions are equipped with General Electric GE90, Pratt & Amp, Whitney PW4000, or Rolls-Royce Trent 800 engines. The extended-range 777-300ER and ultra-long-range 777-200LR variants entered service in 2004 and 2006 respectively, while the 777F, a freighter version, debuted in February 2009. These variants all feature high-output GE90 engines and extended raked wingtips. The 777-200LR is the world's longest-range airliner, able to fly more than halfway around the globe, and holds the record for the longest distance flown non-stop by a commercial aircraft. The 777 first entered commercial service with United Airlines on June 7, 1995. It has received more orders than any other wide-body airliner. As of July 2016, 60 customers had placed orders for 1,893 aircraft of all variants, with 1,417 delivered. The most common and successful variant is the 777-300ER with 665 delivered and 800 orders. Emirates operates the largest 777 fleet, with 157 passenger and freighter aircraft as of July 2016. The 777 has been involved in 6 hull losses as of August 2016. The Asiana Airlines Flight 214 accident in July 2013 was its first fatal crash in 18 years of service. The 777 ranks as one of Boeing's best-selling models. Airlines have acquired the type as a comparatively fuel-efficient alternative to other wide-body jets and have increasingly deployed the aircraft on long-haul transoceanic routes. Direct market competitors include the Airbus A330-300, newly launched Airbus A350XWB, and the out-of-production A340 and McDonnell Douglas MD-11. The 787 Dreamliner, which entered service in 2011, shares design features with the 777. In November 2013, Boeing announced the development of upgraded 777-8 and 777-9 variants, collectively named 777X, featuring composite wings and GE9X engines and further technologies developed from the 787. The 777X series is planned to enter service by 2020. Development background: in the early 1970s, the Boeing 747, McDonnell Douglas DC-10, and the Lockheed L-1011 TriStar became the first generation of wide-body passenger airliners to enter service. In 1978, Boeing unveiled three new models: the twin-engine Boeing 757 to replace its venerable 727, the twin-engine 767 to challenge the Airbus A300, and a trijet 777 concept to compete with the DC-10 and L-1011. The midsize 757 and 767 launched to market success, due in part to 1980s extended-range twin-engine operational performance standards regulations governing transoceanic twinjet operations. These regulations allowed twin-engine airliners to make ocean crossings at up to 3 hours distance from emergency diversionary airports. Under ETOPS rules, airlines began operating the 767 on long-distance overseas routes that did not require the capacity of larger airliners. The trijet 777 was later dropped, following marketing studies that favored the 757 and 767 variants. Boeing was left with a size and range gap in its product line between the 767-300 and the 747-400. By the late 1980s, DC-10 and L-1011 models were approaching retirement age, prompting manufacturers to develop replacement designs. McDonnell Douglas was working on the MD-11, a stretched and upgraded successor of the DC-10, while Airbus was developing its A330 and A340. In 1986, Boeing unveiled proposals for an enlarged 767, tentatively named 767X, to target the replacement market for first-generation wide-bodies such as the DC-10, and to complement existing 767 and 747 models in the company lineup. The initial proposal featured a longer fuselage and larger wings than the existing 767, along with winglets. Later plans expanded the fuselage cross-section but retained the existing 767 flight deck, nose, and other elements. Airline customers were unimpressed with the 767X proposals, and instead wanted an even wider fuselage cross-section, fully flexible interior configurations, short to intercontinental range capability, and an operating cost lower than any 767 stretch. Airline planners' requirements for larger aircraft had become increasingly specific, adding to the heightened competition among aircraft manufacturers. By 1988, Boeing realized that the only answer was a new design, which became the 777 twinjet. The company opted for the twin-engine configuration given past design successes, projected engine developments, and reduced cost benefits. On December 8, 1989, Boeing began issuing offers to airlines for the 777 design effort. The design phase for the new twinjet was different from Boeing's previous commercial jetliners. For the first time, 8 major airlines: All Nippon Airways, American Airlines, British Airways, Cathay Pacific, Delta Airlines, Japan Airlines, Qantas, and United Airlines had a role in the development. This was a departure from industry practice, where manufacturers typically designed aircraft with minimal customer input. The 8 airlines that contributed to the design process became known within Boeing as the Working Together Group. At the first group meeting in January 1990, a 23-page questionnaire was distributed to the airlines, asking what each wanted in the design. By March 1990, Boeing and the airlines had decided upon a basic design configuration: a cabin cross-section close to the 747's, capacity up to 325 passengers, flexible interiors, a glass cockpit, fly-by-wire controls, and 10% better seat mile costs than the A330 and MD-11. Boeing selected its Everett factory in Washington, home of 747 production, as the 777's final assembly site. On October 14, 1990, United Airlines became the 777's launch customer when it placed an order for 34 Pratt & Whitney-powered aircraft valued at $11 billion with options on an additional 34. The development phase coincided with United's replacement program for its aging DC-10s. United required that the new aircraft be capable of flying 3 different routes: Chicago to Hawaii, Chicago to Europe, a non-stop from Denver, a Hockenheim Airport, to Hawaii. ETOP air certification was also a priority for United, given the overwater portion of United's Hawaii routes. In January 1993, a team of United developers joined other airline teams and Boeing designers at the Everett factory. The 240 design teams, with up to 40 members each, addressed almost 1,500 design issues with individual aircraft components. The fuselage diameter was increased to suit Cathay Pacific. The baseline model grew longer for all Nippon Airways, and British Airways input led to added built-in testing and interior flexibility, along with higher operating weight options. The 777 was the first commercial aircraft designed entirely by computer. Each design drawing was created on a 3-dimensional CAD software system known as CATIA, sourced from Dassault Systems and IBM. This lets engineers assemble a virtual aircraft in simulation, to check for interference and verify that the thousands of parts fit properly, thus reducing costly rework. Boeing developed its own high-performance visualization system, Flythrough, later called IVT, to support large-scale collaborative engineering design reviews, production illustrations, and other uses of the CAD data outside of engineering. Boeing was initially not convinced of CATIA's abilities and built a physical mock-up of the nose section to verify its results. The test was so successful that additional mock-ups were cancelled. Production and testing. The production process included substantial international content, an unprecedented level of global subcontracting for a Boeing jetliner, later exceeded by the 787. International contributors included Mitsubishi Heavy Industries and Kawasaki Heavy Industries, Fuji Heavy Industries Limited, Hawker de Havilland, and Aerospace Technologies of Australia. An agreement between Boeing and the Japan Aircraft Development Corporation, representing Japanese aerospace contractors, made the latter risk-sharing partners for 20% of the entire development program. The initial 777-200 model was launched with propulsion options from three manufacturers: General Electric, Pratt & Whitney, and Rolls-Royce, giving the airlines the choice of engines from competing firms. Each manufacturer agreed to develop an engine in the 77,000 lbf and higher thrust class for the world's largest twinjet. To accommodate production of its new airliner, Boeing doubled the size of the Everett factory at the cost of nearly $1.5 billion to provide space for two new assembly lines. New production methodologies were developed, including a turn machine that could rotate fuselage sub-assemblies 180 degrees, giving workers access to upper body sections. Major assembly of the first aircraft began on January 4, 1993. By the start of production, the program had amassed 118 firm orders, with options for 95 more from 10 airlines. Total investment in the program was estimated at over $4 billion from Boeing, with an additional $2 billion from suppliers. On April 9, 1994, the first 777, line number WA001, was rolled out in a series of 15 ceremonies held during the day to accommodate the 100,000 invited guests. The first flight took place on June 12, 1994, under the command of Chief Test Pilot John E. Cashman. This marked the start of an 11-month flight test program that was more extensive than testing for any previous Boeing model. 9 aircraft fitted with General Electric, Pratt & Whitney, and Rolls-Royce engines were flight tested at locations ranging from the desert airfield at Edwards Air Force Base in California to frigid conditions in Alaska, mainly Fairbanks International Airport. To satisfy ETOPS requirements, 8 180-minute single-engine test flights were performed. The first aircraft built was used by Boeing's non-destructive testing campaign from 1994 to 1996, and provided data for the two OER and -300 programs. At the successful conclusion of flight testing, the 777 was awarded simultaneous airworthiness certification by the U.S. Federal Aviation Administration and European Joint Aviation Authorities on April 19, 1995. Entry into service: Boeing delivered the first 777 to United Airlines on May 15, 1995. The FAA awarded 180-minute ETOPS clearance for the Pratt & Whitney PW408 engined aircraft on May 30, 1995, making it the first airliner to carry an ETOPS 180 rating at its entry into service. The first commercial flight took place on June 7, 1995, from London Heathrow Airport to Dulles International Airport near Washington, D.C. Longer ETOPS clearance of 207 minutes was approved in October 1996. On November 12, 1995, Boeing delivered the first model with General Electric GE 9077B engines to British Airways, which entered service 5 days later. Initial service was affected by gearbox bearing wear issues, which caused British Airways to temporarily withdraw its 777 fleet from transatlantic service in 1997, returning to full service later that year. General Electric subsequently announced engine upgrades. The first Rolls-Royce Trent 877 powered aircraft was delivered to Thai Airways International on March 31, 1999. 1996, completing the introduction of the 3 power plants initially developed for the airliner. Each engine aircraft combination had secured ETOPS 180 certification from the point of entry into service. By June 1997, orders for the 777 numbered 323 from 25 airlines, including satisfied launch customers that had ordered additional aircraft. Operations performance data established the consistent capabilities of the twinjet over long-haul transoceanic routes, leading to additional sales. By 1998, the 777 fleet had approached 900,000 flight hours. Boeing states that the 777 fleet has a dispatch reliability above 99%. Initial derivatives after the original model. Boeing developed an increased gross weight variant of the 777-200 with greater range and payload capability. Initially named 777-200 IGW, the 777-200 first flew on October 7, 1996, received FAA and JAA certification on January 17, 1997, and entered service with British Airways on February 9, 1997. Offering greater long-haul performance, the variant became the most widely ordered version of the aircraft through the early 2000s. On April 2, 1997, Malaysia Airlines 200ER named Super Ranger broke the Great Circle distance without landing record for an airliner by flying eastward from Boeing Field, Seattle to Kuala Lumpur, a distance of 10,823 nautical miles, in 21 hours and 23 minutes. Following the introduction of the 200ER, Boeing turned its attention to a stretched version of the airliner. On October 16, 1997, the 777-300 made its first flight. At 242.4 feet in length, the -300 became the longest airliner yet produced, and had a 20% greater overall capacity than the standard length model. The -300 was awarded type certification simultaneously from the FAA and JAA on May 4, 1998, and entered service with launch customer Cathay Pacific on May 27, 1998. For the program's start, Boeing had considered building ultra-long-range variants. Early plans centered on a 777-100X proposal, a shortened variant of the -200 with reduced weight and increased range, similar to the 747 SP. However, the 100X would have carried fewer passengers than the -200 while having similar operating costs, leading to a higher cost per seat. By the late 1990s, design plans shifted to longer-range versions of existing models. A more powerful engine in the 100,000 lbf and higher thrust class was required, leading to talks between Boeing and engine manufacturers. General Electric offered to develop the GE90-115B engine, while Rolls-Royce proposed developing the Trent 8104 engine. In 1999, Boeing announced an agreement with General Electric, beating out rival proposals. Under the deal with General Electric, Boeing agreed to only offer GE90 engines on new 777 versions. Longer-range models. On February 29, 2000, Boeing launched its next-generation twinjet program, initially called 777X, and began issuing offers to airlines. Development was slowed by an industry downturn during the early 2000s. The first model to emerge from the program, the 777-300, was launched with an order for 10 aircraft from Air France, along with additional commitments. On February 24, 2003, the 300ER made its first flight, and the FAA and EASA certified the model on March 16, 2004. The first delivery to Air France took place on April 29, 2004. The 300ER, which combined the 300's added capacity with the -200ER's range, became the top-selling 777 variant in the late 2000s, benefiting as airlines replaced comparable four-engine models with twinjets for the lower operating costs. The second long-range model, the 777-200ER, rolled out on February 15, 2005, and completed its first flight on March 8, 2005. The 200ER was certified by both the FAA and EASA on February 2, 2006, and the first delivery to Pakistan International Airlines occurred on February 26, 2006. On November 10, 2005, the first 200ER set a record for the longest non-stop flight of a passenger airliner by flying 11,664 nautical miles eastward from Hong Kong to London, lasting 22 hours and 42 minutes. The flight surpassed the -200ER's standard design range and was logged in the Guinness World Records. The production freighter model, the 777F, rolled out on May 23, 2008. The maiden flight of the 777F, which used the structural design and engine specifications of the 200ER along with fuel tanks derived from the 300ER, occurred on July 14, 2008. FAA and EASA type certification for the freighter was received on February 6, 2009, and the first delivery to launch customer Air France took place on February 19, 2009. Initially second to the 747 as Boeing's most profitable jetliner, the 777 became the company's most lucrative model in the 2000s. Program sales accounted for an estimated $400 million of Boeing's pre-tax earnings in 2000, $50 million more than the 747. By 2004, the airliner comprised the bulk of wide-body revenues for the Boeing Commercial Airplanes division. In 2007, orders for second-generation 777 models approached 350 aircraft, and in November of that year, Boeing announced that all production slots were sold out to 2012. The program backlog of 356 orders was valued at $95 billion at list prices in 2008. Production updates and improvements. In 2010, Boeing announced plans to increase production from 5 aircraft per month to 7 aircraft per month by mid-2011, and 8.3 per month by early 2013. Complete assembly of each 777-300ER requires 49 days. In November 2011, assembly began on the 1777, a 300ER model for Emirates, which was rolled out in March 2012. In late 2011, the FAA assigned a common type rating to the 787 and 777, allowing pilots qualified on either aircraft to operate both models, due to related design features. The smaller 787 was the first stage of a replacement aircraft initiative called the Boeing Yellowstone Project. Reportedly, the 777 could eventually be replaced by a new aircraft family, Yellowstone 3, which would draw upon technologies from the 787. By the late 2000s, the 777 was facing increased potential competition from Airbus planned A350XWB and internally from proposed 787 variants, both airliners that promise fuel efficiency improvements. As a consequence, the 777-300ER received an engine and aerodynamics improvement package for reduced drag and weight. In 2010, the variant further received a £5,000 maximum zero fuel weight increase, equivalent to a higher payload of 20 to 25 passengers. Its GE90-115B1 engines received a 1 to 2.5% thrust enhancement for increased takeoff weights at higher altitude airports. More changes were targeted for late 2012, including possible extension of the wingspan, along with other major changes, including a composite wing, new power plant, and different fuselage lengths. Emirates was reportedly working closely with Boeing on the project, possibly being the launch customer for new 777 versions. China Airlines ordered 10 777-300ER aircraft to replace 747-400s en routes between Taipei and Los Angeles and New York City, telling Aviation Week in Space Technology that the 777-300ER's per seat cost is about 20% lower than the 747's costs. 4 of the 777 aircraft were already flying as of February 2015. Mindful of the long time required to bring the 777X to the market, Boeing continued to develop improvement packages which improve fuel efficiency, as well as lower prices for the existing product. As of February 2015, the backlog of undelivered 777s totals 278 aircraft, representing just under 3 years of current production at 8.3 aircraft per month, causing Boeing to ponder the 2018 to 2020 time frame. In January 2015, United Airlines ordered 10 Boeing 777-300ERs, normally costing around $150 million each but paid around $130 million, a discount to bridge the production gap to the 777X. Boeing has worked with General Electric to offer a 2% improvement in fuel efficiency to new aircraft beginning in 2016. GE will improve the fan module and the high-pressure compressor Stage 1 blisk in the GE90-115 turbofan, as well as reduce clearances between the tips of the turbine blades and the shroud during cruise. These improvements, of which the latter is the most important and was derived from work to develop the 787, will, GE says, lower fuel burn by 0.5%. Boeing's wing modification will deliver the remainder. Boeing stated that every 1% improvement in the 777-300ER's fuel burn translates into being able to fly the aircraft another 75 nautical miles on the same load of fuel, or add 10 passengers at 2,400 pounds of cargo to a load-limited flight. In March 2015, additional details of the improvement package were published in Aviation Week and Space Technology. The 777-300ER is to shed 1,800 pounds. Boeing will replace the fuselage crown with tie rods and composite integration panels, similar to those used on the 787. New flight control software is to eliminate the need for the tail skid by keeping the tail off the runway surface, regardless of the extent to which pilots command the elevators. Boeing is also redesigning the inboard flap fairings to reduce drag by reducing pressure on the underside of the wing. The outboard raked wingtip is to have a divergent trailing edge, described as a poor man's airfoil by Boeing. This originally developed for the McDonnell Douglas MD-12 project. Another change involves elevator trim bias. These changes are to increase fuel efficiency and allow airlines to add 14 additional seats to the airplane, increasing per-seat fuel efficiency by 5%. In January 2016, Boeing confirmed plans to reduce the production rate of the 777 family from 8.3 mo to 7 mo in 2017 to help close the production gap between the 777 and 777X created by a lack of new orders. 777X program. In September 2011, Boeing released more details on proposed third-generation 777 versions, collectively referred to as 777X and tentatively designated 777-8 and 777-9. The 777-9 was to feature a fuselage stretch of 7.0 feet to a total length of 250 feet 11 in to accommodate 407 passengers, while the ultra-long-range 777-8, a replacement for the 777-200 LR, was slated to be 228.17 feet in length. Wingspan for both models was expected to increase from the current 212 feet 7 into 234 feet, and incorporate the use of carbon fiber reinforced polymer in its construction. In February 2012, General Electric disclosed studies on a new engine, dubbed the GE9X, to power the 777X. Rolls-Royce and Pratt & Whitney also proposed power plants for the 777X, including the RB3025 concept, based on the Trent 1000 and Trent XWB engines, and an adaptation of PW1000G engine architecture to produce up to 100,000 lbf of thrust. However, in March 2013 the General Electric GE9X was selected as the exclusive engine to power the 777X. In May 2013, Boeing's board of directors gave formal permission for its Commercial Airplanes division to start offering the 777X to customers. The 777X program includes two models: the 777-9, which is stretched beyond the length of the 777-300, and the 777-8, which is sized close to the 777-300, but with ultra-long-range capability. On September 19, 2013, Lufthansa's supervisory board gave approval to order 34 Boeing 777-9 aircraft to replace its 747-400s, in advance of the program's official launch. In October 2013, Boeing announced that its U.S. facilities in Charleston, Huntsville, Long Beach, Philadelphia, and St. Louis, as well as Russian facilities in Moscow, would support the 777X design effort. Boeing officially launched the 777X at the 2013 Dubai Air Show in November 2013, announcing a total of 259 orders and commitments worth more than $95 $1.5 billion, constituting the largest product launch by dollar value in the history of commercial aviation. These included orders for 150 aircraft from Emirates, 25 aircraft from Etihad Airways, and 50 aircraft from Qatar Airways. The former two orders encompass both 777-8 and 777-9 variants, and the latter is entirely for the 777-9. By April 2014, with cumulative sales surpassing those of the 747, the 777 became the best-selling wide-body airliner at existing production rates. The aircraft was on track to become the most delivered wide-body airliner by mid-2016.